program on data science prerequisites conducted by the Department of Computer Applications. Let's inaugurate the session with the blessings of God by lighting the digital lamp on data science prerequisites. Now it's time to introduce the chief guest. I invite Dr. A. Bamini ma'am, head of our department, to deliver the chief guest address.
A pleasant morning to you all. Let the day be great. When a prayer becomes your habit, miracles become your lifestyle. First, I pray God to shower His blessings throughout 4 days to conduct the FDP on data science. Next, I convey my gratitude to the Chief Patron, Mrs. Tilakavati Ravindran, President, and Mrs. Aruna Ashok, Secretary Ma'am. Then, I extend my heartfelt thanks to our Patron and Principal, Dr. T. Palanishwari, who acknowledges to carry out the International Faculty Development Webinar. The objective of FDP is to know what is the purpose of data, how to access and analyze it. Now, it is a time to welcome and introduce the resource person of the day, Mr. K.C. RajKumar from USA. He is technologist, savvy individual providing enterprise IT solutions for Fortune 100 companies around 2.5 decades of years. He has passion and interest in designing applications and databases. He is well versed in implementing big data, NoSQL, streaming and message brokers based solutions. He possesses versatile technical knowledge on various proprietary open source software and tools. He is a mentor for SCP graduates. His thirst towards knowledge is widespread, thereby updating himself in various techniques and different domains. Such an eminent personality is in the midst today. Once again, I welcome you, sir. Next, I welcome all the learned participants. Without them, the day will not be fulfilled. Last but not the least, I welcome all my faculty and student team for their complete work towards the upliftment of the FDP program. Finally, I invite the guest of honor to take over the session. Over to Mr. RajKumar sir on the topic Impact of Big Data in the Digital Era. Thank you, one and all.
Thank you, ma'am. Now I hand over the session to the resource person.
Good morning, everyone. Are you able to see my screen?
Yes, sir.
Okay. Thank you. Respected Principal Dr. T. Palanishwari, respected Head of the Department Dr. A. Bamini, respected faculty team of Computer Applications, Chandra Devi, Mrs. P. Lakshmi, and Mrs. V. Vandana. Thank you very much for the opportunity to come and present on International Online 4 Days Faculty Development Program. It's really an honor for me to do this presentation for my hometown college, SFR College, and that's being attended by students and faculties from all over India. So before I jump into that, let me, like Dr. Bamini gave a good introduction about me. Let me tell who am I. So I was born, brought up with everything, did my college and everything in Sivakasi. I went to SKCME school, went to RDBMS College. After that, for my MCA, I went to St. Joseph Street College, Trichy. After completing my MCA, I did work for Hindustan Motors at Chennai, nearby Chennai, outside of Chennai, for 3 years. I was a senior software developer working on like Sybase database applications for their moving equipment division manufacturing plant. After that, I moved to US and started working for a top like 50 financial institutions here. And I've been working here for like 20 years, more than 20 years for this bank, financial institution. Playing different roles, like mostly on data architect, data designing, or anything to do with data. I played all the roles. So that's who I am. And for this agenda, like let's talk about like I'm going to talk about a little bit on like intro on big data, and talk about like what is big data and what's the landscape of the big data. Like big data is so big, so it consists of so many different things. So we are going to talk about that one, and then we are going to provide some resources for you for your like like reading, or like you want to hack something, you can download the software and play with that. So those contains like the resource page will contain all this. So intro. So data is the new oil. This is like the new thing here. Why it is? Because like when I worked for like Hindustan Motors, we had like the entire manufacturing department. Like we had our like the machine manufacturing unit, purchase department, sales department, parts department, everything running on like a 4 GB hard disk base. And we were able to produce, manufacture machines using applications built on like only 4 GB. But right now, we are producing humongous amount of data that we need to store and process. And data is becoming very, very important, because like for business, in order to survive, they don't need to depend on only their data, like their purchase or their sales. They need to see like what's the talk of the town, like Twitter or any other Instagram, or like what's happening outside their forte, like to find out like what's happening, which will be influencing like their product and their services. So that generates so much of data, and if the company does not like change that data and then harness its power and make use of it, it won't survive. So the data is becoming like more like oil, and for any kind of industry revolution, oil was very important. Likewise, data became so important for any business for current digital era to survive, to help the customers, to serve them better and everything. So to start with that, there is a story, like we are right now going through this COVID-19. We have so many other like this social distancing and other problems. But it was started it was spotted by a Canadian startup first, before even government or any other people came to know about it. So during on December 30, 2019, BlueDot is the company name. It's a startup. They alerted their clients, both private and government clients, about there is an unusual pneumonia started to spread. They found it using big data, machine learning, artificial intelligence, and they were able to locate, track, and predict where the spread is happening. It was possible because of big data and machine learning only. I mean, when you look at the data they used health data from CDC. We call it as CDC. It's for Center for Disease Control. They collected data from World Health Organization, and they collected data from other health providers. This health data will tell okay, someone is sick, someone is visiting doctor, like that. But not only that, they collected some unstructured data like news articles, information from journalists, like someone writing from like in China in a blog, like someone got sick. So they were like collecting all those news articles also, and also they collected more information about travelers. They found all of a sudden during that time, a lot of people were leaving that particular town. And based on their previous historical analytics, there were not that many people leaving around that time, but all of a sudden they found so many people leaving the town, and these blogs and news articles popping up with some kind of pneumonia, and also based on the collection of like metrics and data from CDC, they were like trying to figure it out. Something is happening. They didn't find it's exactly COVID-19, but they found something is happening, and they alerted their like private clients and governments, and it led to this COVID-19. It was COVID-19 spreading, but they alerted their government without knowing what was happening. But with the help of big data, by collecting various data 24 hours a day, classifying the data, and building a taxonomy on like relevant keywords, and then apply machine learning on top of it. And like when you collect data from like blogs and news articles and everything, you need to do NLP, NLU, which is like a natural language processing, and to train the system, and then they analyze everything, and that system will produce the results which will be analyzed by human beings, like scientists, whether like that mission prediction, was it correct, was it like how much weightage to it, will it be a real like information, or is it like some false positive. So it will be decided by the human experts, and then based on the research and everything, based on the analytics, they release the information on December 30 before any government form. So that's the world we are living right now. That much of data we are generating, we are like consuming, and our cell phone has got like more than like 128 is like minimum right now gigabits of like storage we have. When you compare like my first production, like entire system model was running on a 4 GB machine, and now our cell phones, a song is more than like 4 GB. I mean like a movie or whatever, like it's more than 4 GB now. So that's why we need to have big data, and that's like Blue Dot's success is because of Blue Data, and that's why data is now the new oil. So we need this data. I mean, it need not necessarily be a startup. Any companies nowadays, every company, if you take financial institution or like insurance companies or manufacturing companies or any startup like Amazon, Walmart, or like any like Flipkart or anybody, they started using this big data because they constantly get information not only from their database, from the interaction from their customer, but outside their comfort zone. They are collecting all this data, feeding into a system, machine learning and everything, and they are trying to find out what the customer wants, how I can serve the customer in a better way, so that they can retain the customer and then they can be in the business for longer time. So let's jump into big data now. What is big data? I mean, as the name stands, big data is nothing but like big data. Along with data, there are like too large, so much information, and then the way like we get that information is so fast. I mean, think like by the time we started this conversation, like and now within this 10 minutes time, I'm sure there would have been like thousands of tweets would have generated. Somebody liked a product, somebody recommended a product, somebody like don't like a product. Many kind of information all over the internet would be passing right now. So that much data is getting generated about a particular product. For the company who is the selling of the particular product, they need to track all those information so that they can know exactly what's happening at this moment, so that they can predict what's going to happen, or they can find a way to sell more stuff for their needy needy people, or like serve the customers in a better way. So that generation of data is so fast, and it's complex also. As I said, like, in the previous example, the data is not just like structured data. It could be a blog, written by some famous person, or like all of a sudden a movie star liked a product, he recommended it immediately, their demand goes like crazy. So, and the way that data coming in would not fit in the predefined structure. So that's why the complexity of the data, the way it's coming, and how big the data, that makes this big data a need for big data. Which, if in old ways, like we do it in relational database management system. Any data we get it, like say sales, we know what are the attributes for a sales, how much price, what is the product, how much is the quantity, information about it, and it's a structured one. But in big data case, we are collecting so many different type of data which won't fit into this relational database concept. So we really need a different technology scope platform to house this data, analyze it, and produce information out of it. So that's called big data. Let's re-look at that slide from BlueDot. See how much different types of data they are collecting. They are collecting structured data, they are like health data, and they are also collecting like non-health related data, which is like in Tamil we say like which means like take two non-related things. Like in this case, like if you think of it, they analyze people traveling from a particular city to another city. When you look that data alone, it doesn't make sense, right? But when you combine with some kind of disease is happening there and people are moving, that two connection of data will produce a meaningful information of like there is something happening. So that's why like the data, acquiring the data is so fast. The data are like in complex in nature, a humongous amount of data they use and they are using every day. So when you think of a characteristics, what makes the big data big data? It's a volume. Like the quantity of generated data and stored data will be so humongous, and the velocity, as I mentioned earlier, it's the speed at which the data is getting generated and processed, and variety. These are the three V's, like how complex variety, like it won't fit in a predefined structure. So having defined this big data, which is like data coming in fast, multiple variety of data, now we need to define the landscape, how we are going to store it, how we are going to process it, how we are going to analyze this data. So this big data infrastructure consists of these 6 components. First one here at the top is the data. So of course big data means like you need to have data, and then once you get the data, you need to compute that data, like to produce meaningful information, and you need to store that data as well as the information. That's the third piece of it, which is like storage. And after storing it, we need to do some kind of analytics, machine learning on it, to determine like to predict something. Like in the example I mentioned, like predict some kind of disease and how it's spreading. And visualization, yes, like instead of like giving them like 10 pages of reports, visualize that content so that people can understand very easily. And also, last but not least, security and privacy. This is more important because like if someone can come and hack the data and take away the data, then it's all this hard work will be meaningless. So how we can secure and how we can put control measures so that like only people who have access can access the data and then interpret the information and the results. So out of these 6, we are going to talk about the first 3 sections today: data, compute, storage. The data analytics and visualization will be And security and privacy will be the remaining every day, like from tomorrow onwards till Saturday. Other professionals will be joining and explaining the other pieces of this, other components of this big thing. So having said that, let's jump into data. As I said earlier, the data could be many different type of data. As I said, first one is the structured data. Structured data is like well defined. You know exactly what are the attributes. If you are purchasing something, you are raising a purchase order, the purchase order will have 30 attributes. If you look into that, most of the organization, they'll have the same attributes. Who is the merchant? What date we are, releasing this purchase order? What is the item we are purchasing? How many quantities? How much value? Standard attributes. It won't change that much. So those type of data are like structured data. And the second one is semi-structured data, which is like kind of structured but not structured. It could have some optional attributes which may come in, may not come in, but like if it's not there, it won't be there. For example, web logs and then JSON documents. Those kind of, it's not 100% structured, but it's kind of semi-structured. It will have structure, but sometimes that attributes may be omitted from the data point of view. And the third one is the unstructured data, which is like web page, blog, images, PDF files, so many data we generate every single day. So now, these data will come in different times. For example, for a company, the data could come real time. For example, if you take a bank, if you go buy a product using your credit card, the minute you swipe the card, immediately the transaction needs to be approved. That means it needs to go through, do some logic, whether you are eligible for that transaction, is it a fraud and everything. Everything will be done real time. And the data will come to the company as real time. So one of the data component like Timespan is like real time data. Then the second one is near real time. This is like, it can take a delay of minute or second, but it will get in little late. For example, you are checking a web page, you look like a product and everything, but that information will get processed by this online website, and then it will be used immediately or like a minute later to send you some email promotions or marketing like that. So it's not real time, but it's near real time. It will help them to communicate back to the customer. The third one is the batch program. Batch program is like batch data. Batch data. The data will come as a batch. For example, monthly payroll running. So in order to run that, you get all the timesheet and you run it every month then. So this data is not real time. This is not near real time. This is once in a month. So what it will do is it will accumulate all the data in a predefined format, and it will come once a month, once a week. So this is a batch data. So now these three ways we can get the data. So one is real time. Second one is, we call it as the NRTF, which is called near real time feed. Third one is the batch. So how these data are coming in, real time and near real time? They are coming through data stream. When we talk about data stream, we have the latest technology everywhere is being used is Apache Kafka. So back to the example I mentioned, the minute you swipe the card, the transaction is coming, and it's coming through it's like a message queue kind of data stream. The message is coming, so and so swipe the card. Then immediately it goes into the system and checks okay, whether this person is eligible to do this transaction. If the amount is valid. If the amount is within his credit limit for this month, for this week. So many computations are getting happen. So the data is coming through data stream for the first two. For the last one, batch, mostly the data will come through SFTP. Say for example, in order to process a payroll, the finance department or the attendance department will send like a employee's attendance in a file like for the past month, and that will be feed into the system to process the payroll. So these are the two ways like data will come, and then the compute will happen. So the compute is the second piece of big data. How it's happening. So as I said, for real-time financial institution, data stream, credit card transaction is coming, and then we need to decide whether like the transaction is a valid transaction or fraud transaction. For example, like you are not using your card, all of a sudden your card is like kind of sending a transaction with like totally irrelevant product that you never bought before. So for the fraud analytics, it goes through like so many validations. It will go back in history, find out like, okay, is this transaction fitting your like spending pattern? So it's doing a pattern analysis, and it will look into this transaction and judging whether it could be a fraud transaction or a real transaction. And everything will happen in like super fast in a few nanoseconds, because it will take like that much time only when the minute you swipe the card, it's approved or rejected. So this kind of compute will happen on the fly, on the data streaming, while the data is coming into the system. The another example is like, say for example, you are on a website like Amazon or like Flipkart or any other popular website. You are searching a product. All of a sudden, like when you go to the next page, immediately it will tell you exactly, how many other people are looking at the same product, or like since you looked into this product, you may be, interested in buying these many different products. And the best example is like if you go look at like Expedia or Orbit, like where like all the tour places or hotel reservation, they'll have like information like, okay, how many people are looking at the same hotel information, or like if you are trying to book a tour, it will say like, okay, if you are interested in this kind of tour, like you may be interested in other kind of tour as well. So these kind of real-time analytics will be happen because of like big data, the way the data is coming in, the streaming, and the way we are computing. And the second one is like a near real-time data, how it's coming in. Like say for example, you wear a watch, Apple Watch or Fitbit or whatever, like it has got its IoT, right? Like it will monitor your sleep pattern. So once it accumulates the data, it may not necessarily send the data in real time and alert you in the middle of your sleep. It sends like in the morning hours, it gets analyzed and it sends the report back to you. So for this kind of processing, you don't need to have a real-time analytics or real-time processing. It's like near real-time. It need not necessarily be immediate, but it could wait for an hour or two. The another example is company website. Again, the product website I was telling, it could be the same thing. Like, based on the usage history and everything, they can find out and then they can use it for email campaign. Like they could send email later on saying like, hey, you looked into this product but you didn't buy it. Would you be interested? Third one is like a batch. When we get the payroll information, how we are doing, how we are loading the data into a database or any other like a storage device, how we are processing it. We use like ETL, tools like ETL, which is called extract, transform, and load, which will process the file and load the data into the data warehouse or data lake, which we will talk into later, to generate meaningful information out of it. So this is the landscape. So now we, like on the left side, data stream coming, like as I said, like it's a credit card information going through this real time, and compute. The popular tools like we use for compute is Apache Flink. Flink is like more like real-time analytics. We use it. Apache Spark is also very popular. So as and when the data is coming in, we use this kind of framework to compute it, and then we generate the data or information. because whatever output it generates, it will be data also, which we will store and use it again, and the information will be displayed in dashboard or reports or other ways. And payroll data, the SFTP is pushing the file to the batch, and ETL will process the data, and it stores the data in the data warehouse. So this is the compute space of the big data. So what we could do with the compute results? So again, as I said, it could be data, because the results could be feed into another system and process again, or it could be information where we can display it through reports or visualization, or we can send the data to some other application through data stream again for it to consume. For example, the sleep pattern, it's coming and we process it, and then if it generates some alerts, it could send the alerts back to streaming, and another process will take it and it could send an email to you or a text message to you. So that's what it is. So now again, the same architecture picture, but the data on the top portion here is coming through our data streams and coming back to the consumers through either a mobile app or email. So these are the technologies we use for compute. Like Apache Kafka is the standard one for message streaming. Apache Flink and Apache Spark are for processing. And Talent is one of the popular ETL, but there are many ETL, even open source ETL tools like NiFi are being. Now, storage. We started with the data, and then we compute the data. Now we need to store the data in a data warehouse to produce some reports or data extraction on top of the data warehouse data. So in order to store it, there are multiple different ways or tools, databases available. It depends on what are the types of data we are storing. And again, this data warehouse could be horizontally scaling, meaning if you need more, since the big data is humongous, if you have 5 nodes and if it's getting filled, adding new nodes would give you a horizontal scaling. And also it should be cost savings, because we are using open source software, and one node goes down, the server application should run fine because of the service availability and the high availability. And not only structured data, unstructured data should be stored. So there are challenges on this one. If you take a regular relational database system, it follows the ACID. If the data is committed, it will be available, and it's all or nothing. It's there or it's not there. Everything will be rolled back. But in big data, the databases which we are going to talk now, they call it as eventual consistency, meaning the data will be sent to this system and it will write in its own time. It will take maybe a few seconds. But if you are building a banking application kind of thing, where if you are going to show the account balance and transactions, this kind of things will not be useful. So for that we use different databases regular relational database. But these databases for data warehouse, most of the time we will be doing analyticals and reports once in 15 minutes kind of thing. So by the time the data will be stored for sure. So that's one of the challenge of these kind of big data technology. So now again, there are multiple ways or multiple database structures available for storage. Popular ones are a columnar database, time series database, key value database, graph database, document, and we can use relational database also, and there is a technology called data sharding. We'll talk about that. So columnar database is nothing but instead of storing it in a row, say for example, if it's HR system, it's storing a particular employee salary, it will be in one row. Instead of that, that information will be stored in a column, meaning all the names will be stored in like one column. I mean, like take each column and store it in a long record. And its benefits are like, you can have a very good compression, and like when you pull the data out, say for example, you are trying to compute like aggregate sales for a product for a given month. You don't need any other attribute. So if it's a regular database, it's going to, based on the block size, it's going to retrieve the entire record, and then it's going to eliminate like, okay, I don't need it. But here, it's columnar database. You need only the sales column. It's going to read that one long record and filter out like, okay, I'm looking for this particular date, and I'm going to take that one, aggregate it, done. So the popular columnar database like Apache Cassandra, it was used by Facebook, produced by Facebook, and open sourced, and then Kudu and ClickHouse. The second one is like a time series database. It's like anything event based, like at a particular time this event happened. These databases are optimized just to store that kind of data. So it's mostly used in like a DevOps kind of platforms, like monitoring server resources or like server logs and everything, because it produces so much data where like we want to know if the server is like CPU utilization, like at that particular time how much it was, and then like we can correlate like, okay, at that particular time what other things were running on the system to find what caused this CPU spike. Now those kind of things we can do it. Another use case is like clickstream, like like at particular date time, user click this, click this, click this. So all this information can be extracted from the web log, and we can find out what is the user's pattern on a website. Like, okay, he went to this website, he clicked this link, he went to that link, and it showed the page, and then from there he looked at that product. So from that like time series data, a business can understand where this user wants to, I mean like what kind of product he likes, those kind of information the business can get it. The third one is key value database, which is more like a dictionary kind of thing, which will have for a given key what is the value, which are like used mostly in session management, product recommendations, and ad servicing, user preference. Like for a humongous website, their preferences and everything will be stored in this key value database, and it is very useful on the preferences and session management. Almost like nowadays every website for session management, like they use like this key value database. The popular one is Redis. Graph database. This is based on the graph theory and based on the nodes and edges. It's like easy to find my friend, who are all my friends, and then for the particular friend, who are all his friends. That kind of graph structure, the data will be stored in that way, and then in order to travel through the graph and find the nodes and vertices, and then like get the other associated node, which is very easy graph database. It's popular in like more like customer, like for example, like in financial institutions, it's being used to find out, okay, this customer is having this product by this customer, and then for this product they are using this. So for association, like a graph and the structure they put it, so that for a given customer they can, when they pull, it will bring all the products that customer have purchased from that financial institution, as well as other related data of that one very easy. Neo4j is the open source popular graph database. Next one is document database. It's getting popular right now because of like a lot of semi-structured data are coming in, JSON based data. Now like the designers, architects, they don't want to bring that semi-structured data in a structured format. They want to store the data as it is, and then they want to like use like a programming language to interpret the data. So in order to do that, they came up with this document database, which will like store the JSON data as it is, and then read it and interpret it. MongoDB is the popular one for this kind of data store. And the final one is regular relational database. Like there is a technique called data sharding, which is nothing but, say for example, like for a particular website, there are like thousands of clients. Instead of like creating like all the clients' information in one database with multiple tables, what they do is they do like shredding. Shredding means like they pick like first 100, put it in a particular database, like an independent database. Like if you take MySQL, they will have thousands of MySQL database servers running, and each database will have 100 clients, 100 clients, 100 clients. And for each client, they will create the same number of tables, so that like in the middle layer, when the particular user hits, they will see like, okay, this user, which database this user is residing on, and then they will forward that request to that particular database to store or fetch the data from that. Popular one is like Instagram. Instagram started like that when they started it. Instead of using like this big data, like a different database concept, they use the regular database, but like they use the data sharding to shard the data and then spread it across into multiple, same version of like data structures, but multiple databases. So now the next one is, this is like data lake. This is what's happening in the enterprise world right now. This is what's going to happen for the next like 10 to 20 years in computer industry. Since data is the new oil, everyone looking into the data. Like the COVID example we were talking about, they are using every single data. Like for example, we may think like the weather data may not be useful. Weather data what? Like what's the weather here? Like in United States, whether it's going to be snow, blizzard, what's the weather look like? Whether the people will come out to the shop or not, that will be determined by the weather data. Even though by looking at the weather data, it's like purposeful, like to tell the weather forecast, it's indirectly used for the business to determine what my sales is going to be. It's look like for tomorrow. Do I need to produce this many for tomorrow, or do I need to reduce my production? So many informations are like calculated based on this. So in order to house all this different data, we need not only a big data, but we need a data lake. So right now in industry is like how to build this data lake. There are standard procedures and every like architecture available. If we follow that architecture, we are fine. So again, like in this big data lake, we are going to store all kind of data, like structured, unstructured, semi-structured, everything, and we are going to continuously push all the data into it, and we are going to continuously analyze the data, blend the data, and then we are going to extract data out of it and then distribute it to the application to make the necessary decisions, like whether we need to send alert, we need to send like emails, or we need to send the production department to manufacture more. All these things are happening. So there are like 6 like features. Like one is the collect, and then once we collect the data, we need to ingest this data into this data lake, and then we need to blend. Like we need to like get this weather data, we need to get the production data and mingle it and see like extract like meaningful data from it, and then we need to apply rules on top of it and transform it, and then we need to publish this findings, and then once we publish it, we need to distribute it either through data extract or like again through stream. Whatever the methods, we need to distribute the data so that the application will take it and use it. This one talks about the difference between data warehouse and data lake. I do not want to go in detail about it. Like we can learn, you can go through it. Like mostly like data warehouse is for structured data and for like business analytics, standard reports and everything. But data lake, the main feature of data lake is the data is going to be there. Say for example, like if you want to go back 1 month before and see the data, and then you come up with like some new algorithm. You want to be like, oh my god, let's use this algorithm and see whether we could predict what happened. So you can take the 1 month before data and apply the data chronologically, and then you see like, oh, okay, this is working. Because we store all the data in its own the raw form there in data lake. We are not transforming anything. All the data will be stored in a raw format also in the data lake, which we are going to see. So that's why like data lake is very popular now. So the characteristics are like it's a centralized single place and it's schema-less. Why I'm saying schema-less is like we are storing the data as it is in raw format, and while reading it, we will apply a schema to it and say like, okay, this data is of this schema, and then the schema and data together will give us some meaningful information. And then we store everything, and then we analyze it. And why data lake? I explained already, like right now with this environment, we need to collect every single data to understand the user behavior, the customer behavior, to serve them faster. So this is the big landscape of data lake. On the left side, we already saw like data stream or batch. Not only that, the DevOps will produce a lot of data. The API calls produces a lot of data. The IoT devices, watches, cell phones, location data, humongous amount of data are coming in from users. So we are going to collect it on the left side, and then once we collect it, we are going to bring it in, ingest the data in two ways. One is either a real-time Kafka or through batch. Once it's ingested into that, then we are going to blend the data, transform the data, and then we are going to publish the data. So what we are going to do is, there are multiple zones inside this data lake. The first one is transient zone. So what we are going to do is, the data as it is, we are going to store it here. It's temporary location, like a scratchpad kind of thing. We put it in a temporary location before we move it to the destination. So that's the place called transient zone. And then raw zone. Raw zone, we collect the data in, say for example, in transient zone, we dump the data. It's like the data contains, like, say for example, it contains like credit card account, it has transaction, everything. And in the raw zone, we put it in credit card account, in account zone, we create a zone in the raw zone, and transactions will be in the transaction. We create those structured, not structured, but like hierarchy. And then we store the data as it is. We may apply like encryption and security and everything, but we keep the data as raw as it is. So once it's there, then we are going to take that data and then process it, like apply like a quality tools and validations and everything done, and then we put the data into a trusted zone. So we have the same data. See, like right now, the transient zone, the data will be removed after a day. The raw zone, the data will be there forever in a raw format. And then once like the data is cleaning is done and validation is done, it's moving from raw zone to trusted zone. Like the raw data will be here also, and we will have another copy with the clean data here in the trusted zone. This is where we give access to like users, data scientists to go look into data discovery and all those things. And then refined zone is the enriched zone. This is where like we apply all our machine learning, data analytics on the trusted zone, and we refine it, and we store the refined data in the refined zone, which will be used by data scientists and data analysts on the right side. So now these contains like every technology, like how we collect the data, check the data, and mostly we use Hadoop for data lake. So in Hadoop, like you can create multiple different zones and everything, and then you store the data for like a 1 day for like intermediate storage, and then store it in a raw format, apply the encryption rule and everything, and then take the same data and process it and clean it and everything, put it in the trusted zone, open it up for data scientists and programs, machine learning and data analysts, run the analytics and take the results and put it in the refined zone. And all this data could be like, again, like go through data stream, which is up here on the top, or API, or we can compute the results and store it in a data mart, which is like a structured data which will be used by dashboard or other reports. So this is the big, all I talk, it's like that here at some point, like we collect, we inject through Kafka, and multiple zones here, raw zone, trusted, refined, and then when we publish, the published data will be consumed by applications, or it will be consumed by reports, or like some visualization technique to visualize the results. So now these are the popular, these are the resources which I always go look at it to get myself up to date. The first one is the O'Reilly Conference Archive. Like O'Reilly is like it's a popular book company. They started this conference business like 10 years ago, I believe, and they are very popular. But with this COVID-19, they shut it down. But all their conferences, like top PowerPoint presentations, will be available free. Sometimes like a couple of videos will also be available on the first link. So you can go read. This is the first place I always go to learn new technology. And of course, like their books, some of the books they give away free, and you can find so many about data lake, data science, data engineering on this second link. The third one is the Hacker News. Hacker News is the place where I always go to learn anything new, like what's happening in our industry, what's the new language, how people are using the particular tool, or like what's happening in the data world. Everything is available in the Hacker News. And BlueDot is the company, the first example I quoted. And then the last one is the highscalability.com. This one will help you to understand like how to architect a highly scalable application. So they always like use cases of like Instagram, like I learned about the data sharding, used by Instagram on their website. So they put their architecture, break it down, and they explain in a simple way to understand all these latest features, or how companies are doing business, how they are using the data, analysis, or like how they are building like crazy websites. It's all available. That's a very important, good website where you can go. One of the things they do is every Friday they do links about like what's happening in the technology industry, which is very interesting. So in order to implement this big data, let's say like in our financial industry, yes, I work and we do it in the financial industry. What we do is we create this big lake. So what's happening is like when we get like we get like a near or real-time data, we get like transaction data. So the minute like the user swipe the card, we get the information, right? So which we call it as authorization, whether like the information is valid, we got a credit and everything, which will come, and we store this information in the first zone, raw zone, as well as we get the data in a batch also every night, like how many, like for all the users, how many times they swipe the card, all the transactions, all the account information, like like yesterday's balance. After all these transactions, what is the today's balance? And not only that, we get like the nature of the transaction. For example, we call it as addendum. So if you use the card for like travel, it will tell us like, okay, what airlines you are going, or like what train ticket number, which train, which start city, which end destination, and everything that we get. Like if you are using that card for like buying in a grocery store, which will have its own like addendums, like what you are buying and everything. Sometimes like we get detailed level. Like if you are renting a car, we know exactly, we get details about which rental company you are using, and what is that, every information about the rental we get it. So we get like one transaction, we get this much humongous amount of data. If you are buying a TV, buying a cell phone, every information will be passed in as, most of the time it will pass in as addendum, and those information will come in. So now all this information will go in to this data lake where we store the data. So near real-time data is also coming and getting stored there, and batch data with the everyday night, like all the accounts and transactions and what type of transactions, what they did, everything coming in and getting stored there. So now all this information are available in a raw format. We apply like cleaning rules, meaning like we do sometimes like the data coming in may have some kind of data issue. Most of the times, like if they are like good, but sometimes we have seen problems with coming in with the data. So we apply our cleaning rules, we validate it, let me go back. So we validate it and we refine it, apply encryption logic and everything, and then we create this trusted zone. Now this trusted zone will have humongous amount of attributes and different types of data. In our example, we have our account, credit card account number, information, the transaction, your addendums, everything. Now, suppose like an analyst, data scientist coming in and asking like, okay, we need to figure it out, like, what is the spend burden of a particular organization. So if you need to know about it, they may want to see what are the attributes there to find a perfect data analytics or the data dashboard, or like some kind of data science I want to do it, so that I can predict what a particular organization is spending on right now and what they could spend next month. So the main thing they do here on the trusted zone is two kinds of people will work on it. One is like a data scientist or data analyst, and another one is like data like programmers. The first one will do a discovery. They want to know what kind of data is there, like it's a transaction. It comes with like humongous amount of attributes. Most of the time, at that particular point in time, like we may not need that data attribute, which may not be useful, but as time pass by, that attribute will become more valuable. So the data scientists and analysts always look for like, okay, what is this attribute? What it means? So if you look at it, there's a data catalog there. That's where they look at it and they find like the definition of it, and they'll be like, this one is very useful. I want to use it. So they will try to, code, or like there are tools available which will be, I think they will talk like tomorrow or day after tomorrow on analytics. Like one of the tools they use is Tableau. Tableau is like a dashboard kind of utilization tool, but we can go find attributes and everything and then find out like what it is and quickly see or like prototype it. The data scientists, they will quickly prototype using the tools available and see like whether it's useful or not. And then if they find it useful, they'll ask the programmer, hey, I find this attribute in yesterday. I want to use these attributes. Could you implement this kind of solution? I want to do a machine learning on this based on this analytics. I want to do this. They will come with the requirement, and and then data programmers will be like, you could do it. They take the requirement, they will do it, and then they will deliver it. Once it's delivered, it's going to produce some information, or it's going to be data again. So that's what's stored in refined zone here, or it could be stored in data mart as well. And then it will be used as for dashboard and analytics report, or like send alerts, those kind of things. So having said that, we have any questions? Like, can I take any questions? I think.
Sir?
Yeah.
Thank you for your wonderful presentation. Queries from the faculty in the chat box, sir.
Oh, okay.
Can I list one by one, sir?
Yeah, I can go through it. How big data analytics play a role in big data analytics in healthcare industry? Okay. Big data is being used in like every industry right now, including healthcare. Healthcare is nowadays, like with COVID-19, it's more useful than ever, like before. It's not only that, again, as I said, weather data. Say, for example, in USA, we'll have a flu season in like October, November. Like it's when like after August, from summer we will go into the cold weather. When we go into that cold weather, we'll get like sick, mostly like cough, cold, and all those things. That's our flu season, and it varies based on like the weather pattern, and also so many other categories, like how many people getting sick. I mean, every year flu types will vary. So these data scientists need to go get all this information. And again, as I said, like these kind of information is like coming from different sources, different type of data, everything coming in, and then like they take it and they take their patient information. They get like, okay, their hospital group will have multiple doctors, and they will see like, okay, this doctor got like 2 flu patients, this doctor has got like all this information going into the big data lake, and they are like analyzing all this. So it's everywhere. Again, this data lake and big data is not on a single industry, universally used by every single type of industry. I mean, the best example is stuff like that BlueDot company, how they found COVID-19 is the best example of like how it is being used in healthcare industry. It may not necessarily be the same healthcare like like big hospital group need to do by themselves. Sometimes they lean on like companies like BlueDot. Here is my patient data. We are storing it in the cloud. You take it, analyze whatever it is, and give us back information. They are doing that kind of information also.
Sir, a participant is asking, can you give a real world business examples for data sharding?
Oh, data sharding? Okay.
Business application, business examples.
Not like Instagram, right? Let's say like, okay, let me tell you. Say for example, I'm thinking of like, from Hindustan Motors, my experience, like how I can tell, or like manufacturing. Say for example, there is this big company which is producing parts, right? Like this is the Honda car company. It has got dealers all over India, right? So this Honda company has got like, they need to know how many number of cars are like, what kind of problem they are getting, or everything at one single place. So in order to do that, they could dealer, and then you can create a table called car, and then you can create a table called dealer car, which will tell like who is the dealer, sold what kind of car, and then with that, from that, like you can see like what kind of problems or maintenance thing happen. So you can have a table called car maintenance. Think of these 4 tables. You have dealer, car, which will like which dealer sold which car, and then what kind of maintenance. Now, if you are going to store this one, for every single city, there is a Honda dealership. So, humongous amount of data is going to come in every single table. Now, it's like not easy to maintain when the data grows so fast. So, in order to avoid using this latest and greatest technology, what their startup will do is, they are comfortable with the database, right? So, they will be like, okay, I'm going to stick with the database. So now how I can do it? So now I need to store this humongous amount of data. So I'm going to use the data sharding. What they do is they take this dealership ID. So it's going to be a number. So they partition it 10 ways, right? So they apply the modular function, MOD, the function call, and then passing this dealer ID, which will be giving a number between 1 through 9, right? So it's going to be always one of the number. If it's based on the dealer ID, if it's 1, it's going to be 1 all the time. So now, for example, this dealer ID falls into the first bucket. They take that one and then they go to that server, because that particular dealer's information will be available on that server. On that server, they'll have these 4 tables for that dealer name. So they create the database as the dealer name .db, and if you open it up, you will have these 4 tables. So you have the car, you have the maintenance, who are their customers, everything for that dealership. And then now they can run whatever extraction or analytics on it. They can run it. If they want to run across all the dealers, they can extract the data, bring it in the middle, and they can do it. So they started doing this way when they were like in the startup, like Instagram and other people, like data shredding, like they were doing it when they were like small, when they don't have time to put like resources into this latest and greatest database technologies. So that's why they are doing like a data shredding, which is like simple. They can write the code very fast, and it's the same structure. The basic middle layer, what we do is that this particular dealer information, which server it is. They do the mod function and find out which bucket they are, and they go in. I mean, if you look at it, the entire architecture will be the same thing. All this big data, database server or everything, they have nodes at the bottom. They distribute the data at the bottom layer. You can add more number of nodes at the bottom layer. And in the middle layer, they have this program which will tell like where that particular data is. Data shredding is like manually we are doing it by creating multiple, the same database for every dealer. But like these big data technologies knows how to spread the data. Not only that, if we pull one node out of that cluster, they know, because they have more than one copy of the same data in multiple nodes, and they know how to pull the data back up even if the one node is going down. So if you look into the technology, it's all the same. One is like manually doing, which is the data shredding. Other way is automatically, which is like all these other big data. Hope I answered the question.
Sir, any tools are available for big data, sir?
Tools in the sense like, yes. Let me go back to the present. Okay. What I'm going to tell is everything is like open source. Left side, this is the big data landscape, data lake, everything in here. On the left side, data streaming is through Kafka. Kafka is the number one. It's being used currently. Every enterprise, every industry you take it, for streaming, they use Kafka. For batch, they use some kind of ETL tool. ETL is extract, transform, and load. There are some open source tools available called Pentaho. And I can send you the list later on, but like, Pentaho is the open source, and there is one more called Apache NiFi, NIFI. NiFi is the tool. So they use it in the middle layer, And then for data analytics and everything, that's where real stream analytics, they use Apache Spark. It's a framework, but you can use Python. Python is used left and right for any kind of machine learning. If the students, or if you are interested in machine learning, Python is the language you need to learn, because it comes with the libraries that are predefined with the algorithm. You don't need to reinvent the wheel. It's all done, and all you need to do is include this library and call this function and pass in the data set. It will do it. And more than tool is very easy on machine learning and data analytics. There are two math papers that we need to learn. First one is linear algebra. All these vector, matrix manipulations, because we need to understand, if there is a problem where we need to predict something, we need to know what kind of algorithm we need to do. So that's that. The basic foundation is linear algebra. The second one is statistics. If you know this one with the Python, and then on top of it, PySpark is the one, and then Apache Flink. PySpark is it's like a kind of batch. It started with batch analytics, but then they remove the batch and then they wait for say a few seconds, accumulate the data, and then analyze that data. But the Flink is so popular because the minute one data, user click this coming in, you can analyze on that particular event also. So Apache Flink, Flink, and Spark, it's there. So those are the things are used in data analytics, and Python is the tool for machine learning and analytics. And I'm sorry.
Thank you, sir, for your wonderful thought-provoking speech. First of all, I thank Almighty for making this session wonderful. Next, I thank our chief patrons and patron. Without them, we cannot able to conduct this wonderful session. Sir, your speech was wonderful and thought-provoking. What you have mentioned about the big data, the need of the day. The talk might reach the participants and they will carry out research using the global digitized big data. The participants have posed many queries. I will send to your mail ID so that we can be able to send their answers. Once again, I thank you all.
Thank you very much.
Gopika, can you wind up?
Yes, ma'am. Thank you all. Thank you for joining us today. Participants, please fill your feedback form.
You can reach out to me. You feel free to share my email. I can reply, if they have any questions or if they need further directions on other tools and everything.
Thank you, sir.
Thank you. Thank you, ma'am.
Live stream off பண்ணிட்டீங்களா கங்கா? லைவ் ஸ்ட்ரீம் ஆஃப் பண்ணியாச்சா? ஹலோ?